Good morning, good afternoon. I am a cloud architect in developer relations team at Palo Alto Networks. And I will talk about container security best practices. I've been working on containers since last about 4 years as a developer and now as a cloud architect. I would like to share with you some of the container security best practices that I have seen people miss. This is more of a checklist. I won't give you point recommendations on what to use. I will tell you what things you need to secure. How you do it is a separate talk. So why do we care? Why are we talking about this? There was a recent survey, I think it came out last month, from Tripwire, that surveyed IT professionals who have some containers in production. 94% of them are concerned about security. I would like to meet the other 6% who are not. 60% of them have had some container security related incident in the past year, and they're expecting that number will go up in 2019. 47% of them have a vulnerable container running in production. So they know about this vulnerable container that's running in production, at least one. And the shocking fact is about 46% don't even know if they have any vulnerable containers in production. So that kind of tells you that security is it's a concern and we need to talk about it. Here's another interesting graph. What are the main concerns about securing containers? And the top ones are not having adequate knowledge about the technologies, and securing not having visibility into container image security, and lack of tools for developing secure containers. Those are some of the top ones. So, oops. Security shouldn't be an afterthought, especially with containers in picture. Security can be part of your development process. It's never too early to start securing your container environment. If you're following CI/CD workflow, you should have security in each step there. So I really like this quote. I saw this quote on Business Wire. There's a belief that you have to accept a significant amount of risk to take advantage of containers, but that's not true. Security can and should be embedded into DevOps lifecycle, incorporating vulnerability and configuration assessment of container infrastructure to monitor risk from build to production. That's just more elegant way of saying security should be part of your DevOps lifecycle, not an afterthought. So I'm not sure if people follow this. I certainly don't. But if you follow yoga and meditation, there's 7 chakras to clean your energy or something. So it's interesting. I wanted to talk about 7 container security areas, and it matched with this 7 chakras. So I'll start from talking about build security, move on to network security, host security, container runtime security, orchestrator, orchestrator configuration and security, then data security and securing your cloud. So first of all, securing the build pipeline. That's the source of your infrastructure. That's where you're starting to build your applications, your CI/CD pipeline, and image registry. So the first point is verify the image that you're pulling. Make sure you're pulling the correct image. You're not being man in the middle. There's no man in the middle attack. Someone's not putting a vulnerable image or a rogue image in the registry. So verify the image you're pulling. Scan scan the container images you pull for vulnerabilities. This is one of the low-hanging fruits that everyone should be doing. Scan the configuration files for security and compliance checks. So by this point, if you're attending this talk, if you're attending HashiTalks, you are aware of security as code, infrastructure as code. Everything is, you're probably using Terraform and other automation tool where you're defining your infrastructure as configuration. So most people have those things version control as well now. So when you make changes to them, make sure you check that kind of configuration in the CI pipeline for security best practices and compliance. Do a static analysis of your code and the dependency. It's a basic one. And then as an organization, you should limit the number of allowed base images. You shouldn't have, like developers should be able to choose some base images that you have done proper analysis of. So if you're building a container image, the base image shouldn't be any image out there, limited to some official images, and even within the official images, some distributions. Number 2 is securing your network. Securing the network is really important because a lot of attacks happen through network. Network is almost always involved in any cybersecurity attack. Container security is not an exception there. So my first recommendation is securing your internet-facing workloads. Any service that you have that is internet-facing, it should be firewalled or should be behind some sort of security. I believe most attacks on any container environment that has happened until now, they all had some sort of combination of this, right? Some workload that was internet facing and it wasn't secured. Another network security is lock down your layer 3 and 4 services using something like network policy. So by default, your container-to-container communication should all be not allowed. You disallow all the communication in the cluster, and then you whitelist which service needs to talk to which other service. Just whitelist those flows. So creating those layer 3 and 4 network policies. If you're using Kubernetes, it's network policy. Next one is creating granular layer 7 policies using something like service mesh, for example, Istio or Console Connect. You should have a fine-grained layer 7 policies on which services are allowed to make what kind of HTTP requests to which other service. So you can be as specific as service A is allowed to make GET call to service B on this port. That will be with in combination with network policy. Using MTLS for container-to-container workload communication. Again, you can use service mesh for this, console connect, Istio, for example. And last one is log all the unsuccessful connection attempts. You might not be able to log every single connection attempts, but unsuccessful ones are important. You should know which connection attempts, which apps are attempted to connect to some other apps and they're failing. It might be misconfiguration, but it could also be an attack. Next one is host security, securing the host where your containers are running. Locking down the host is important. If you have a host file system that is accessible through containers, making sure you lock down write and exec permissions on the host, so random processes don't get write and exec access to the file system. An example of this is Google's COS, Container Optimized OS. There are a bunch of other OS examples out there. Using seccomp to restrict host syscall access. So this is listing which syscall containers are allowed to make on the host. This kind of provides isolation between container and host. So containers cannot make all the unnecessary syscalls. And next one is similar, using SLNX to isolate containers. So the first one, seccomp, was to isolate containers from host. This one is more talking about isolating containers from each other, as well as from the host. And a fourth one is securing your container runtime. This is sort of a new dimension that was added. If you were used to virtual machine security or traditional security, this vector wasn't there. So container security, container runtime security is important. Container runtime depends on which container runtime you're using. Docker, CRI-based container runtime implementation. So number one there is reviewing your default configuration settings for the container runtime. When you start the container runtime, this is on each node. How is the default security configured? There are some default configuration rules for each of the container runtimes. Make sure you understand that. The second one is similar. Ensure that whatever policy you applied for one container runtime is applicable to all the other ones in your environment. What I mean is you can have some nodes running Docker as container runtime, let's say, and some others are running CRI-O or CRI containerd in a different cluster, or could be in the same cluster. You need to make sure the security policy you have configured is uniform across all of them. Third one is restricting the use of privileged containers, not allowing privileged containers or allowing them on a per need basis. This is important. You shouldn't having a privileged container kind of defeats the purpose of having containers at all. Privileged container means container has root access to the host. So limiting that by default, you can do this at orchestrator level, and which is fine, as long as it's covered by someone. And the last one for that, for container runtime security, is restricting access to container runtime daemon or APIs. If you're using Docker, Docker, long time ago, they moved from having REST APIs to Unix sockets. So they're trying to reduce the surface on who can talk to the Docker daemon, because, as you know, bringing down Docker daemon, it messes with the cluster. It's not a good place to be in. So securing the container runtime APIs is important, and restricting the API access to only the tools that need it. Orchestrator is one, third-party apps, the trusted third-party apps, etc. Fifth area is securing the orchestrator configuration. Make sure that cluster level policies go through some sort of review and approval process with infrastructure as a code, security as code. A lot of things are now more easily accessible to even people writing the app. Developers and DevOps teams have access to these things, and it's very easy to make changes. Make sure you have some sort of policy in your organization to have these changes, especially when it comes to orchestrator configuration, things that impact the entire cluster. Make sure they go through some sort of review and approval process. Securing orchestrator API access through RBAC, and having them behind some sort of network policy or access control list. That's very crucial. Not everyone and everything should be able to access the orchestrator APIs. Beware of all the third-party plugins and applications you're installing on the system. So orchestrators like Kubernetes, they have many well-defined interfaces, CNI, storage interface, CRI. So you could be deploying many different plugins in your environment. Understand what plugin you're installing, what permissions they need, and try to minimize the access, the API access. Don't just have a whitelist for this plugin so it's able to access all the orchestrator APIs. And you can, that brings me to the next point. Even for third-party apps, you should use RBAC to create some sort of service account or a role to limit which APIs they have access to, and as well as what operations they're allowed to do. Most orchestrators allow you to do that. Next one is enabling access log for all the API requests. Some sort of audit trail on who is making all the changes and how those changes can impact your environment. So you can go back and see who made these changes and when was this change made and what exactly changed. And the last point is scanning the application manifest for security best practices and compliance. Now, what I'm talking about is how you define your application in your orchestrator. For example, if you're using Kubernetes, your deployment manifest, service manifest, namespaces, network policy, etc. All those things that go with your app, make sure they go through the same process for automated security best practice and compliance checks. Oh, I don't know why this looks like this. Hold on. Okay, now it's better. Number 6 is securing the data. This is for this one, make sure you use a proper file system encryption for your container storage. Understand the pros and cons of different file system encryption technologies, and choose a proper one. The default one might not be the best one for you. Next one is providing write and exec access only to the containers that need to modify certain data paths on the host. Not all the containers need to have write and exec access to your whatever is mounted as if you're mounting a host volume to the container, it doesn't necessarily need write or exec access. Make sure you're doing the you're limiting the attack surface there as well. Next one is scanning the images for sensitive data in the CI. Sensitive information like tokens, private keys, OAuth tokens, etc. Make sure they are not leaked. If you have a public image repository, or even if it's within your organization, make sure you're not putting the sensitive information doesn't get leaked to the repository. You block publishing that image in the CI. Next one is limiting storage-related syscalls and capabilities to prevent runtime privilege escalation. This is kind of self-explanatory, but you should only have certain containers don't need to make a lot of storage-related syscalls that you don't know about. So having a profile that limits those capabilities is important. So at runtime, some malicious container or process doesn't do privilege escalation and do a whole bunch of things. And the last one is similar to my previous points, is logging attempts to whenever some app or someone tries to access some sensitive data, make sure you have some sort of logging system that attempts that logs all the attempts, not just unsuccessful ones here. And the last one, last area that you need to secure is the cloud. If you're hosting your container infrastructure in the cloud, you need to understand the default security configuration. For example, if you're using a hosted container service, hosted Kubernetes or hosted container service like ECS or EKS, AKS, GKE, understand the container runtime they're installing by default. Understand the operating system, the host operating system they are installing, and what are the security configurations there, as well as the orchestrator itself, the version of orchestrator you pick, and the vulnerabilities it might have. The CNIs they're installing, and different cloud providers have different environments. So understand the default security configuration for that, and then go from there. So you understand what is your baseline. Next one is understand the version of orchestrator and container runtime that is provided to you by your cloud provider. If you're using hosted one, hopefully you have done some research and you're going for a specific orchestrator version and specific container runtime version. One point I forgot to mention here is also you should have some sort of policy or something that's monitoring version of container runtime. You might not, you don't want to end up with some host running an older version of container runtime that is not secure and has some vulnerabilities that you're not aware of. It's easy to have monitor images, container images for that, but not container runtime version itself. And the last point is similar to my other points, is you also need to secure, or this is more of a shift left security, right? the configuration you use to set up this environment, cloud environment, Terraform template, CFT, ARM template. Make sure you check those also for security best practices and see if there's any compliance misalignment before you actually go and deploy the environment. Catching this early on could save you a lot of trouble. So in conclusion, these are like 7 areas that I consider you need to secure. As I said, this is more of a checklist on what things you need to check, not specific recommendations on how to do it. There are many tools, vendors, and projects that allow you to let you secure each of these areas and individual points. But that's outside of the scope of this talk. And with that, thank you. I think I only have 2 minutes left. If there are any questions.
It looks like there are some questions that people have been asking. You go to the Q&A box at the bottom.
Okay. All right, let me see, hold on. Okay, all right, let me see. Oh, open, all right, sorry. What are some scanning tools for CVEs and security compliance check in container images? Some scanning tools are, for example, Claire from CoreOS is one of the famous ones. It's an open source tool for scanning your container images for CVEs. Compliance check is something different. Palo Alto recently acquired a company called Redlock. Companies like Redlock do that. All right.